So the stage is yours, Piotr.
Okay. Thank you for coming. I know it's very hard to be on last presentation in any conference, so I won't waste your time. Let's go to agenda right now. We'll go through the social proof, why I feel I'm entitled to give this talk, then why up and running doesn't mean scaling, then going through days 2 to 1,000, but I don't want to spoil the fun right now, and of course closing arguments. So I'm cognitive DevOps. I specialize in fixing technological stacks of scale-ups and making their software development lifecycle again fast and reliable. I work with over 20 companies in my career with 9 different markets. And I've built many Terraform projects, refactor both of lines of Terraform code. And this talk is about going through one of these transformations. Also, this talk is something that is powered by my second brain, which I'm really passionate about. So here you see like this freckle is about Terraform, and it's distilled knowledge. I work with Terraform since version 0.8, even once migrating 0.7 to Terraform almost 1. And I've worked with GCP and AWS clouds, even with Azure enough to hate it. And the one lesson I want you to have in mind when I give this talk is that scalable Terraform isn't an overnight success. I modeled this talk up for 1,000 days, so it's 11 quarters, almost 3 years. And of course, your mileage will vary how fast you can do that, but it's usually enough even for the most complex setups to go through the Terraform process, and even if you have your day-to-day work. So all the journey starts with, of course, the day one. And who started with this book? Only one person? It's that old? I was there 3,000 years ago, and this book was, if anybody was doing Terraform, he started doing this with this book, because it was really good for the times. So we didn't have any kind of community yet. The tools were in very alpha stages. There were no good practices available, no tooling, nothing. It was just the entry point. And after this book, you have the repository that looks like that. You have the local modules, and you have some live environments like stage and the production. And what's the problem with this repository? It doesn't scale. If you have more and more resources, this type of writing the code doesn't scale. It's really easy to write code, but of course, it was only perfect for learning, not for maintaining large organizations with Terraform. If you're using more than 2 people to develop the code, then this approach is not optimal. So we have the problems of day 2. Day 2 problems are the problems that arise when the organization didn't think about something or forget about something, and the critical problems arise on the day that the application is released to the production. So with this, these day 2 problems can be for a long time, for a year or 2 years or 5 years, still the same. And what I'll tell you about the day 2 problems, for me, is usually the starting point for the work. So the problem is that the organization still have this kind of repo, that it didn't evolve past the tutorial. So we have the manual state, that's local. We are using the Terraform from our local machines. We have modules that are also local, and we don't have any kind of CI/CD, any kind of good practices. Terraform is maintaining like whole environment, and it's taking like 30 or 40 minutes to change. And if you will try to make it from scratch, then it will time out because there's too much resources in this code. And what I thought paradoxical enough is that this code is not scalable while it's providing the scalable architecture. So you have something like this, typical Terraform repository for enterprises and scale-ups. You have this for a team, or domain team, plotted live stages, the modules that are submodule for like super repository with all the modules available. And all the teams share this module because it has many interesting modules that are needed and are common concerns. But of course, with this, you don't know which version did you check out because nobody thought about it. So these modules may work with one repository, don't work with the other. And if you need some kind of new feature, new version, and keep the backward compatibility, then you create the new module, which is the same, like the previous one, but a little bit different, but still the same, but different, of course, and you have to maintain, like now, 2 of those. So it's not the greatest solution, and of course, each re-architecture of this, with this state, takes longer and longer, so you try to find something better, right? And the worst part is, with this big chunks, if something breaks in Terraform state, you have big area of impact. Anybody had corrupted Terraform state and fixed that? Oh yeah, many people. Yeah, it's no fun. It's no fun at all. So day 3, it's a free tip. I know what you will say about it. I know that you know that I know. The basic is that the state, of course, is having all the information what was deployed. But still in 2024, organizations use local. Don't use local state. It's bad practice, even if you will encrypt it. The proper backend is, of course, remote. It's locked, so no 2 people work at the same time. It's encrypted. It's restricted with airbags, so nobody from the public internet can access it. And it's better to have multiple smaller backends than the one big one. And of course, back that up, because sometimes you can delete it and find yourself by surprise that there is no state. So now, day 31, we are seeing that infrastructure as a code is not working as it was advertised. Your dev team is frustrated that you cannot provide new environments as quickly as they want. Your DevOps team is frustrated because it's working with the bad code. So the business is telling you to refactor it, and it's giving you a month. Who believes that in moderately sized code base, you can refactor Terraform code in 1 month? Yeah, no hands, no hands. I also don't believe in success, but 1 month is enough to understand the cloud you are working with. So, for example, in AWS, you have the concept of the separated accounts. And in GCP, you have folders and projects. And these concepts shape how you should think about your cloud resources and setup of your cloud. It's really good that both of these clouds have cloud foundations, so you can read about good practices, what you shouldn't be doing, and the common happy path use cases. And I recommend you to read it, but of course this talk is not about the clouds, so I will skip it, but it's a good starting point. And you can understand the Terraform code better in 1 month. So Terraform, of course, is infrastructure as a code that helps you to provision and maintain resources in the cloud. And what you need to understand is the Terraform is for things that change relatively slow. It's the tool that helps you provision something, then it runs without your input, and then you can easily come back and see what was deployed and how it was configured. But it's not for things like, for example, local exec and remote exec, because they are slow, its execution is not safe in the state. And you should use other tools like configuration management tools like Ansible, Puppet, Chef, Packer, and so on. So try to avoid these two, because if you are using those, in 96%, there is something bad with your architecture and how you think it should be done. Now, also, don't use TF workspaces. It's a feature that's there, but it in theory, lets you have different configurations, but the same code. So with using this kind of variable and this list of different workspaces, in theory, you can have different var files for different environments. But it creates problems, like with prototyping and new versions. If you want to create new resource that only needs to be in the testing environment, not the prod environment, then you start to have ugly ecology of the code. So if the workspace is X, then do Y. And with that, you have complex reasoning, because you are looking at the code and you need to understand the code, the workspace you are working, and the variables that are there. So also it will be obsolete by the end of the journey I'm trying to talk about. Now, with that, we must understand also that Terraform is not the perfect tooling. It will make some hard decisions along the way, painful investments, going slow at the beginning, because slow is smooth, smooth is fast, and of course hard decisions, what to do, what you should prioritize and what not. So by the day 90, you understand the cloud and the tooling, and you can remove temptations as the first step. So nobody is allowed to change the production manually. You set up the specialized service accounts to create resources, and of course make the exception for people that are supposed to maintain your cloud. So in time of the incident, they can do much more. No more ClickOps, especially in the production. So ClickOps is when you create the resources for the web portal. Of course, exception for sandbox environment. If you know that it won't be a dependency for any other person, you are just trying things out, you can do ClickOps to understand tooling better, but then you should be able to destroy it without the problem. And for test environments, it's better to execute Terraform locally, to have faster iterations than going through the whole CI/CD process. Now, right now, if you made the mistake of the ClickOps in production, you can really easily import resources to Terraform, and even Terraform can generate the config, the Terraform config. It's really great because it's the starting point. It's not 100% accurate, but it's really good starting point to import your resources. What you must think about is that this resource shouldn't be deployed by other Terraform code, because then you have mice and cat. Like two Terraform code will try to change the resource and they will never be in sync. And what will help you with those is resources on your, what will help with tagging your every resource. It helps with billing to know how much cost is generated, with data to understand what's in your cloud, with control, for example, to set up some virtual machines to close on the weekend, and with discovery. One of my favorite tags is giving you information which Terraform repository deployed the code. So when I need to change something, I can very easily and quickly see what repository I need to change. It all helps with understanding, so you should think about your strategy regarding the tags in your cloud resources. Now, day 150, you are still starting. We can talk about good modules. From this, like super repository module, which is really, really bad because it doesn't scale, we can talk about anti-patterns. First, it's having local modules. Yes, they're easy to write and easier to test, but maintaining them is really, really hard. So companies usually go from this local module anti-pattern right into modules proliferation. So they are creating many modules that are really similar. There are a splash of, for example, S3 modules that are doing the same almost, and you don't know which one are needed, which one to maintain, and which one to destroy. And right after that, the companies are going to the second side of the same coin, which is mega modules. They're taking few of the modules that are doing the same and creating mega module that is really bloated because it's aimed to cover all possible use cases. It's starting to be brittle and really, really complex. So what is a good module? Good module is small. It's really simple. It's hiding a large volume of knowledge about the cloud and the setup behind a very small surface of the API. It contains all the security practices that your organization needs or has to be done, and of course best practices. And what's the most important, if the module isn't opinionated, then it doesn't add any value. What I mean by that? This is typical S3 bucket module. It's very generic. I have to configure it with almost everything that can be configured in S3. And right now I can just write my own S3 bucket resource and will be the same for me. Good thing is to have specialized modules like this. This is the module to create public website from the bucket. And this is the module that creates S3 for the backups. They have different lifecycle rules, different rules about the security, different IAM rules, but they're really easy to use. And I don't need any kind of specialized cloud knowledge to set it up. I just need it as a value that I'm adding as a domain team expert. So I need to host my websites. And this is the module to do that really easily. And it's a good place to talk about variables versus locals in Terraform, because variables, especially in modules, should be for controlling what is deployed. So all the important things that you want to change between each execution of the module. And the locals are for the guardrails. So the user cannot change them. You can have here the values that are hard-coded from the perspective of the user, but not hard-coded into the Terraform. And if the user wants to go from this path that, for example, we are requiring versioning, then he needs to change the whole module. He cannot just opt out of it. And the reminder, of course, with Terraform variables, you can also have sensitive. So you mask the values from the logs and outputs, like credit cards, emails, passwords, parcel numbers. And which is even more important, you can have validation block in each of the variables. And it helps you to shift left your security concerns and good practices, because right here, for example, we are forcing that the end variable will be either staged on production. We are not allowing anything else. So if someone makes a mistake or tries to make something because he's smarter, then he won't be allowed to use this module. Now, do you know what this module does? Looking at the files? Probably not. It's this website S3 bucket. But looking at those files, you don't know because they're really generic. So it's always better to break down the files for easy discoverability. Right now, from this file that had over 100 lines of code, we created S3 mostly, and other, of course, but this S3, the biggest file, has now less than 50 lines. And it's more easier to change the code, and also Git likes much more the smaller files. So, of course, if you created resource modules, you should tag them. It's a no-brainer, good practice. And right now with that, we've come from the modules that are local to just using code, using modules in the code like it should be, with the versions that the service do need. And it's almost a year. It's day 300. It's time to day-to-day work of the cost center. So we have different problems, like balancing out between the technical debt, new features, maintenance. There start to be talks who should maintain the Terraform code application teams versus code Terraform team. How much does it cost, this change, and the waning passion, because we are still in this very slow pace of work with the baselines. And it's really important to this day-to-day work to make good Terraform code, because you need to understand what value does it bring in the organization, what the organization values, what is the most important thing, how the teams work, how the sprints work, and everything. So you shouldn't skip the day-to-day work with making better Terraform. And right after the New Year's party at your company, you start to notice that Terraform has different speeds. So you have the environment of different speeds. Stage changes constantly because you are testing things, and the production changes only when the stage is stable and ready to, be deployed. And right now, if this repository is like this, if someone has access to this repository, he has access to stage and the production, so he can make mistakes, for example, with copying code from here to there, which is really not great in terms of role-based access control and things like that. You also have resources of different speed. So here we have the shared Terraform code that's responsible for like network and management and security. It changes few times in the life of the company, while the services Terraform repository changes quite often. And you have teams of different speed, of course, because maybe this service alpha is more important for the company, it has more developers, so they develop feature faster, while service beta is more in the maintenance mode, so the Terraform doesn't change like that. And with that comes the observation that your Terraform code should be like on the way representing your cloud strategy and architecture. So you have the bootstrap layer. Like, for example, basic infrastructure in terms of AWS will be accounts. For GCP, it will be folders and projects. And you start with that. Then you create resources that are global for your organization. So for each account or each project, you are set up in logging, security, and the roles the same for every project you have in your cloud infrastructure. Then there is infrastructure foundation layer, things like identity access management, Kubernetes, or other things that are global for the units, so the account, for example, but are tailored to the domain teams. And there are bases to pull the services, the value. And of course, the services are all the things that your domain teams need to run their applications. Service layers are then built onto the opinionated modules that I talked previously. So how to build that in the way that will be scalable? With microinfrastructures. What? Microinfrastructures? What? Microinfrastructures, yes. That's the idea from Pavel, how to name it, because I'm naming it differently before. They are serving one purpose, and by the halfway of the work, with better Terraform code architecture, we are trying to build it. So let's have this service, Alpha. It's one of the services that we need. First of all, we are taking that from this big repository, and we are separating repository. So we have the staging Terraform code, and we have the production Terraform code for this service alone. Now, what's important? This one will be secured by rule-based access control. So only senior developers can push to main with force. And everybody needs approval to, for example, run CI/CD for this repository. And of course, secrets will be separated. And for the staging, which is like playground, whatever, you can set the rules as you want. This only the staging. So how does it look, the main file in that? It's micro infrastructure module that is having everything to set up this whole stack for the domain team. In this example, we have containers for the Cloud Run, we have pub subtopics, we have notification channels. And what's important, that's only one module. And what's even more important is that it's versioned. Why it's important? Because we can work in different kind of environments. And while the staging, for example, changes every day, the production will only change when we tell it to. And with that, there are benefits and the cons, of course. The benefits are, it's auditable because we know the production repository is deploying code in version 1.0. It has shortened deployments because the code is smaller, of course. It's simpler, clear separation. It's easily shareable because if we have some kind of structurized workloads in our company, for example, deploying some kind of websites with the same way, we can create the stack for it and share it between the teams. The rollbacks are really faster right now because instead of thinking what was deployed and when, we can just change the version of the micro infrastructure. And of course, the production is then secured and lower environments can be kept with more loose rules. The cons, of course, is much more, but smaller repositories. Quick fixes require whole the process, like the dance of change coming, tag, push, check, and then again. Local work is a bit harder because you cannot work with these microinfrastructures without the hack, which is a little bit ugly, but I can talk about it after the presentation. And you really need good documentation and tagging, because without that, then you'll just drown. Now, from the left side that we have really big Terraform repository, we are going to multiple environments, and we can easily add another one if business wants that, and one stack for the micro infrastructure that is powering all those three, or even more. By the day, 650 CI/CD, because if we want to move fast, we need a solid foundation. Of course, that could be done much more earlier, but I need to go like time in one direction, and I thought that it's less important than modules or micro infrastructures. So good CI/CD starts with the tooling. Which one should you use of those? It really doesn't matter. I'm an open source guy, so I would just propose to you to use your own container that has Terraform, Cloud SDK, and all the tools that are required for your process. It's much easier, and you can then just migrate from one solution to another with that. What should be in CI/CD? But it shouldn't be more complicated than it needs to be. We start with Terraform pre-commits. So each time someone even thinks about committing the code, then goes Terraform format and Terraform docs. So the code will be nicely maintained. It will be clean code, let's say clean code. And the docs will be also auto-generated, so you don't do manual labor, but your README is looking nice. Then you commit and push, and the CI/CD does Terraform init and validates. So it downloads the modules, downloads the providers, checking if the versions are not colliding, checking if it's had access to the backend, and so on. Then goes tflint, so static analysis. If you are not writing Terraform code for a few years, then you probably need some kind of good code practices and sanity checks that are made by the people who done that more than you. Because if you will do it in an automated way, nobody will argue with the bot on the PRs. So you can identify potential errors, stylistic errors, suspicious constructs in the code, and of course bugs. It's really easy to set up. You just create the file with the rules. This is example policy, like I am not allowing anything that won't be used in the Terraform code. And I'm forcing naming convention because I don't want to have the errors with the interpolation of the variables in the Terraform code. So it's really easy to set up. It can be set up for every environment, and then you have Terraform written in one way in your whole organization. Now, inject data and the secrets is the next step. I will skip that in CI/CD, and OPA infra calls also, but I will talk about it a little bit later. And of course, then comes plan, apply, notify the team that it changed. You can do the drift detection and check the Terraform code a few times a day, week, month. But there's something missing here from the usual textbook CI/CD. Do you know what it is? It's testing. Nobody tests the code, right? So I personally have problems with that. You have many tools like TerraTest, Kitchen, Inspect that test Terraform, but with declarative languages. Like, what are we testing? Are we testing, does the Terraform work? Or the providers are written as it should be? Are we testing if the cloud APIs are working? What are we testing with the Terraform code? I'm not paranoid enough to test the testing things. I'm not paranoid enough to test the providers. I trust them. So what we need to understand is that the Terraform code creates infrastructure. But infrastructure does not create the value for the company. What creates value is the application that's running on this infrastructure. So just use application integration testing to test if your environment is working as intended, because that's the most important. But of course, local static is really cool if you want to quickly iterate and you don't have money to that on AWS. Now, day N100, data and the secrets that you are providing to Terraform code to be more dynamic. Should you use remote state to get the information what was deployed? As a last resort. More likely, you should use data sources and check, for example, what kind of subnets are available or MIS are available in your cloud. Or you can use key value stores. For example, Vault, which is also great for secret management. It's really nice that it has provider for the Terraform, so you can just check with data source the values and inject them into their code. And CI/CD or your repository doesn't need to know anything about the secrets. It's only in the runtime. So we have day 900, and we can start talking about security. I prefer Open Policy Agent. There's also the Sentinel, which is Microsoft solution that's really, really, really important. Great. Sorry, it's not important, it's really expensive. But it's important for the most companies to run because it's really good. Open Policy Agent, on the other hand, it's compliance and security as policy. And it's good to make sure that nothing that we not deem value will be deployed. So Rego is really simple language that is really hard to learn. And here we have the rule that we are only allowing N2 instances, and if not, we'll deny to deploy code, and the patterns of the naming of some resources. So we have nice cattle environment. Also, if that won't be the case for things that they want to deploy, it will be denied. And what is really good about Open Policy Agent is that it's really universal. So we can use it for Terraform code, Terraform plan, let's say, for the Docker or container images, for the Kubernetes admission controllers, for the Kafka topics, for the APIs authorization in general, and for SSH. So it's really one tool that can solve many problems with security and authorization. And last but not least, there is also talking about the costs, how much this infrastructure will cost you when you deploy it. And with that, I have only one solution that kind of works. It's good estimation at the beginning. It's about 50% accurate, but still it's good enough to start talking about the cost of what you deploy with Terraform and, for example, have the quality check that if someone wants to deploy something that will cost $10,000 a day, they will be stopped. Now, closing words. First of all, I hope I managed to convince you that up and running doesn't mean scaling. If you want to have scalable Terraform code, you need to have opinionated modules. You need to understand layers of your infrastructure. You need to use micro-infrastructures and have CI/CD, of course, with good guardrails for security. But the testing, not so much to have the good code. Now, beyond cloud, you can use Terraform for other things, like source control, creating repositories that are set up in a specific way. That will be much easier to create new ones with good practices in mind. For example, what is the main branch, who is the code owners, who can run the CI/CDs and so on. And of course, set up other HashiCorp products. You can just check the providers in the Terraform and see that there's vast ecosystem of things that Terraform can configure in declarative way. And of course, you can also go beyond Terraform with internet developers platforms like Crossplane or Backstage to use Terraform for minimal things and use more modern things for the things that change more fastly, where Terraform is not shining as a tool. So, also hope that you have this one lesson in mind still, that scalable Terraform isn't overnight success. And from the day 1 to 1000, well, this presentation was a bridge that will help you to go through. So, thank you very much for listening to my talk. And if you have any questions, I'm open to it.